Hi, this video looks at what happens to CO2 chemically. In this diagram here you can see a hydrocarbon molecule which is reacting with oxygen, and the products from the oxygen will be water from the hydrogen on the hydrocarbon and CO2 from the carbon backbone. So where does that go? Well, you'd imagine what will probably happen is the water will join in to the watercourse, here the sea, and also the CO2 will be dissolved into the watercourse as well. In a long period of time, you can see in the background the needles, which is containing quite a lot of calcium carbonate. This is data taken on the Californian coast. You can see there's a seasonal variation. In summer, the photosynthesis takes place and oxygen is produced, and the CO2 is bound in to create food for plants. But what is also clear is there is a slower rise in the amount of CO2 present in the atmosphere, as we might expect. But at the same time, the ratio of oxygen to nitrogen is dropping, more or less following the same time scale as the CO2 rise. This graph here shows the concept of atmospheric potential oxygen, which is the dynamics in the biosphere between oxygen and CO2. Maybe CO2, but is not really lost as being available oxygen. And so the observation that we have of the CO2 concentration, for example, relates to three different factors. What is generated by fossil fuels, what is taken out of the atmosphere by the dissolution into the oceans, and then this swap between CO2 and oxygen in the biosphere. These plots are from ocean measurements. The CO2 again, as expected, is rising, and also there is the seasonal variation. But the graph also shows that pH is dropping as the CO2 pressure is increasing. When pH is dropping, that means the concentration of acid is increasing. We can represent the chemical processes here. CO2 dissolving in water produces the bicarbonate anion, but also protons, the source of acid. And then in the second line, there is a competition between the binding of calcium to carbonate and the release of bicarbonate from calcium carbonate. So with more acid, that equation will go to the left. The concentration of calcium itself is pretty constant across oceans. It's around 0.4 grams per litre, which is 10 millimolar. When you start to make this more difficult, this precipitation of calcium carbonate, one of the first things to happen is the loss of the ability of sea creatures to make their shells, many of which use aragonite, that form of calcium carbonate, as the mineral that makes up their shells. So in the near future, I intend to create little videos on water and ozone, looking at the effect of their presence on the greenhouse effect. And then we'll look at methane and nitrous oxide. And finally, some of the more pernicious and long-lived species, which could be a big problem in many years to come.